Now let me give you guys a practice problem here. Real easy practice problem. Okay? Two practice problems. Let's say we want to find the inverse. When I say f negative 1, I mean the inverse of this equation. Okay, first of all, let's say y equals 2x plus 5. And y equals x squared minus 4. Find me the inverse of those two. Remember what I said, you want to switch x and y, and then get y by itself again.
Are you turning this then?
Yeah, put this on your practice problem. If you want to work with a group, that's fine.
Yeah, I'm not 100% sure what this is.
What do you have on your second? What do you have on the second one? Well, the first one's easy. What's the second one?
First one's easy.
Yeah.
Yeah, on the first one.
No, you're trying to get y, right?
No.
Or y equals, so you're trying to get x.
We're trying to get the inverse.
Right, so it would be x minus 5 over 2. But I can't get the second one because it's a cube.
We gotta figure out, in order to get rid of the cube, we have to do square root of x is x, the square root of negative 4 is well, negative 4 can't be square root of.
Right.
It should be x minus 5.
It's just the first one is square root of 2.
The opposite of squaring is you did 2y plus 5 equals x.
Really, I know she's did I get that one right?
So I'm going to I'm not even looking at that. I'm looking at that.
So g minus f would be 3 minus x cubed. Write this down. 3 minus x cubed minus this stuff. So 3 minus x cubed minus x squared plus 2x. Okay, and then plug in 2.
I mean, I get most of it.
Yeah.
8.
You're supposed to find the inverse.
No, minus 4, because it's minus 2 squared, so you square that and get positive 4, but then you still have to subtract it.
Oh, okay, well,
That may be what you're doing. And then that's nice, because those kill each other.
That makes sense because it's not actually
It's not a minus
2.
2 squared, it's minus 2 squared, so minus 4.
Scale and negative -5.
Mhm. Yep.
Now, on the actual practice question we're trying to do.
Yep. Can we do it up here?
Yeah,
Okay.
that would really help. 'Cause I feel like I work better with an example.
Switch x and y in the equation. Okay, so what would it look like if I switch x and y in the equation?
X minus 5 over 2.
No. What if I switch x and y in the equation? I didn't say tell me the answer. I said switch x and y in the equation.
X equals 2x
y minus 4.
X equals 2y plus 5. I switched x and y in the equation.
Oh, is that simple?
Not quite.
Well, then you have to solve for both.
Now once you switch x and y, you are no longer talking about your function. You are talking about the inverse function. Okay? So all I need to do to make my inverse look nice is get y by itself. So I want to get this y by itself here. So what do I need to do to get that y by itself?
Subtract 5 from both
Subtract 5
sides.
from both sides. And that gives me equals 2y. X minus 5 equals 2y.
And then divide by 2.
And then divide by 2. Okay, so my inverse would be x minus 5.
That is the inverse.
That is the inverse.
No, I can do that, but I can't do like f of g plus whatever.
So we don't even fill out the first equation because we're just doing the second one?
Don't solve the first equation. Well, the first equation is already solved for.
See, my problem is I did all that in my head, and then I'll probably want that on paper, on a final or something.
Not necessarily, no.
Oh, I hope not.
That's true.
Okay, this is the inverse. So my original function is this. Then this is the inverse of that function.
So our question is how would we graph that?
You don't need to graph it. If you do want to graph it,
I would do the
graphing calculator.
Oh, there you go.
Okay, so what was my original function? 2x plus 5?
Yes.
Okay, and then my second one is x minus 5. Remember, put that numerator in parentheses. Divide by 2. Okay? See how if you made a diagonal line, they would be symmetric. You could pull them across that line. That's because they're inverses. Okay? So on that calculator, you just do y equals. On there, you know how to use that?
No.
Okay. You go to hit y equals.
I know how to turn it on.
That's a good start. We'll hit y equals, put in the equation, and then hit graph.
Oh, okay, got it.
Okay, but we probably don't really need to graph that. I didn't ask to graph it. I just wanted to find the inverse.
Yeah, I was just asking if like we wanted to verify that we got it right.
Yeah. Oh, we don't tell you if you got it right. Okay, what about this one? What if I switch x and y here?
X equals y squared.
X equals y squared minus 4. Okay? Now I just need to get y by itself. Okay, so I'm going to add that 4 over here. So I get x plus 4 equals y squared. No, divide by 1. The opposite if I square root y squared, the square root of something squared is just itself. So the square root lets me get from y squared to just y. If you divide by y, that's going to give you a y on the left again, and then you've got two y's, and then you're going in circles. Yeah. So then it's impossible to get y by itself that way. The only way to get rid of the square without messing anything up is the square root.
Now, are you going to take out that 4?
Nope. Can't do that. The square root has all that trapped in. Store it. You can't break up the square root across the back. Alright, and that's it for that one. Alright, so let's look at a couple homework problems here, because that's really all I have to say about that. Because I'm guessing you guys need a little more practice here.
Are you going to open up assignment 4?
No, we're just finishing.
Okay.
We're just finishing this here.
Okay.
Now, do you guys understand what these bubbles mean here? With the arrows? It's just like a table, yeah. So it's, instead of writing the line down the middle, they just have this. Okay, so they give me a function up there. This is number 17. And I want to find my inverse. So what am I looking for here?
The opposite.
First check to make sure there's no repeats in y, because that's where they'll try to trick you. If there's repeats in y, you would choose D. No inverse. Okay, now I don't see any repeats in y there. So I'm just going to flip the x and y. So the y bubble is going to become
The X bubble.
X bubble, which is the domain.
Right.
And the X bubble is going to become the Y bubble, which is the range. So that is
B.
C. Yeah, you want to look at the one up at the top to figure out which one you want to flip. So what about the next one? What about the next one?
B is disqualified.
There's repeats in Y. So look at what would happen if I did flip it. If I did flip it, I would choose B. But what's wrong with B? It has repeating x's. B would be considered not a function. Okay? So we don't like B because it's not a function. So really I could switch that if I wanted to, but it's not a function. So it can't have an inverse function. It's not a function. Okay? So really it does have an inverse. The inverse is just not a function. Okay? Now be careful on the quiz, because it may give you one on the quiz that is okay to switch, and it may give you one that's not okay to switch. Okay? And everybody on the quiz for some reason just switches it without thinking. And then they get it wrong sometimes. Okay? This one? What about this one? 19.
Sometimes it's easier if you take those and you put them
In a table?
Well, yeah, vertical.
I agree. That can be easier. So let's take these points and make an XY table, and then we'll look at it. So my points are 3, 1, 2, 6, 4, 3, 6, 1.
And you have repeating Y.
Repeating Y values. Yes. So again, they are trying to trick you. So that is not one-to-one. It has no inverse. Okay, so these are easy where I just click that it's undefined. I like that, right? I don't really have to do anything. Okay?
Was that 20?
20.
I was kind of just like clicking and looking ahead. What?
Oh, you want to find the two composite functions, f of g and g of f?
No.
So you want to plug g into f, and then you want to plug f into g.
Right.
So if I plug g into f, well, f of x is 13x. So for x, I would plug in g.
Okay, yeah, so it would be
X. And g of f of x is 13x over 13.
So it would be x.
So it would be x. So yes, they are inverses of each other. Because both of those composite functions are both equal to x. I was trying to find one where we actually have an equation here. It's just a table. Another one here. A lot of these are pretty quick. Okay, here's one, number 26. Look at 26. You guys can skip to 26. Just pause whatever you're doing. You can always come back to it. Look at 26. Okay, is the function one-to-one? How do I tell if it's one-to-one if it's not a table?
Do you want to know just by looking at it?
I can't tell just by looking at it. I need to look at the graph. So if they don't give you points to look at, you need to look at the graph and use the horizontal line test. Okay? So I do need to look at the graph. If they give you an equation, you need to look at the graph and use the horizontal line test. Okay, so what was my equation here? 8x minus 6.
Agreed.
Okay? Now, is that one-to-one?
Yes.
Yes, because it passes the horizontal line test. Okay? Now, just to give you guys a clue, basically if you don't see an x squared is where you get that u shape. That's really the only functions that have problems with being one-to-one. So if it's just a line, a linear function like 8x minus 6, it is going to be one-to-one. Okay, so I can say yes on that. And then they're going to ask me to find the formula for the inverse. Okay, so again, how do I find the formula for my inverse? Substitute y for x. So I start off with f of x equals 8x minus 6. That's the same as saying y equals 8x minus 6. Okay, to find the inverse, I want to substitute x and y. So I want to switch x and y, I get x equals 8y minus 6. Okay, then I just need to get y by itself. So I want to add 6 to both sides. And then I want to divide by 8. Okay, so I end up with y equals